Welcome to the deep dive. Today we're tackling an idea that really turns our view of the universe upside down.
It certainly does.
We usually picture things, orderly, planets orbiting nicely, galaxies spinning predictably.
Clockwork universe idea, right.
Exactly. But our source today, it's excerpts from The Chaos of Motion, Why Life is the Most Random Structure in the Universe. It presents something radically different. This motion theory, it suggests the universe isn't just made of motion, it's defined by it.
And motion at its core.
Is fundamentally random, the most random force we see, apparently.
Which is quite the claim.
It is. So our mission, let's say, is to unpack this. How does this theory argue the universe is built from structured rhythmic motion, but motion that's constantly experimenting? The book uses phrases like loops, collisions, convergences, and chaos.
Leading to unscripted surprises. Like that phrase.
Me too.
Yeah.
But it begs the question, if it's all so chaotic, why does anything look stable? Why isn't it just mush?
A fair question.
And what does that chaos mean for you listening right now? Let's explore.
Let's do it.
Okay, so to get a handle on this, let's imagine a cosmic tour. Motion made visible. Start big. Galaxies.
Hello.
The sources call them spiraling roulette wheels of space. And they are not uniform. Not even close.
Right. You see incredible variety.
You've got clean spirals, sure, but also these jagged blobs. Some are alone, others in clusters. Some are even crashing into each other.
And their orientation, their spin, it's all over the place.
Yeah, no galactic template whatsoever. It feels messy.
Well, that's where the source brings in this concept of localized sync chaos.
Sync chaos. Explain that a bit.
Think of it like, okay, imagine a chaotic system like turbulence in water. But within that turbulence, you get temporary localized patterns, like little eddies.
Okay.
So in a galaxy, all the parts, stars, gas, dark matter, they're all moving, interacting randomly. But they lock into these unique feedback spirals. They find a temporary dynamic stability within the chaos.
So it's not ordered, it's just settled chaos.
Yeah,
locally.
pretty much. Unique motion loops that found a temporary balance, which, raises the next question.
If the biggest things are chaotic.
What about the smaller stuff? Stars, planets.
Right, and the book dives right into that. Stars and planets, it calls them cosmic coin flips with gravity.
Yeah, I like that too.
Forget neat formation. Stars emerge from violent, irregular densities and gas clouds, just messy clumps.
Which leads to that huge range we see.
Exactly. Tiny red dwarfs that last trillions of years versus hypergiants gone in less than 1 million. Some alone, some in pairs, or even threes. It really feels random.
And planets, the source says they're even worse.
Worse? How so?
Well, in terms of randomness, you get planets baked too close to their star, others deep frozen out in the dark.
Right.
You get planets spinning sideways like Uranus, some are tidally locked, always showing one face. There's no standard model.
So no blueprint?
None. The book calls every planetary system a random remix of collapse patterns, angular momentum, and sync accidents. Yeah, cosmic improv.
Okay, so if stars are random coin flips and planets are these wild remixes, how did we end up here, on Earth, in the Goldilocks zone?
The Goldilocks zone.
We hear that phrase all the time. Not too hot, not too cold. Simple, right?
Well, the source argues it's far from simple.
It really pushes back on that. Says there are actually dozens of Goldilocks conditions all stacked together that had to get this. Go wrong just right.
Go wrong just right. That captures the improbability.
It really does. I mean, think about the list. Our specific distance from the sun.
Critical, obviously.
Our orbit's shape, its eccentricity stable enough. Our tilted axis giving us seasons.
The moon. Can't forget the moon.
A big moon stabilizing our wobble and driving tides. Then there's having the right kind of star, a magnetic field to shield us.
Plate tectonics, regulating the climate over eons.
Water existing as solid, liquid, and gas. The right atmospheric mix. Even our collision history.
You mean the impact that formed the moon?
Yeah, the right kind of catastrophe. Big enough to make the moon, but not so big it just vaporized everything. It's mind-boggling.
And connecting this back to motion theory, the source says each one of these is a motion loop that settled into the narrowest possible sync band.
Narrowest possible?
Extremely narrow. Think of it like tuning dozens of different radio dials to exactly the right frequency all at once, purely by chance.
Wow.
These aren't designed conditions, according to this view. They're a cascade of improbable sync accidents. Temporary stability emerging from chaos.
And the book is stark about the implications. Change one tiny thing.
And complex life might be impossible.
Huh.
No dinosaurs, no mammals, no humans, no ants. Nothing like what we see.
Which really makes you ask, just how rare is any life then?
Exactly. How improbable is this sync accident we call Earth?
And okay, even if you get a planet like Earth, the randomness doesn't stop. Life itself, it wasn't a straight line.
Not at all.
Earth didn't just make life, the book says. It launched millions of motion experiments.
Constantly trying things out.
Think about it. Life starts in the oceans, then somehow adapts to land. Huge shift. Creatures evolve with no eyes in the deep sea. Others develop infrared vision. Plants use sunlight.
While others deep down use sulfur from volcanic vents. Totally different energy source.
And lifespans. Hours for some insects, centuries for some trees or clams. It's just wild diversity.
And the theory explains this using recursive paths of biological sync loops.
Recursive paths.
Yeah.
What does that mean practically?
It means the underlying machinery, the basic motion loops in your cells.
Mm-hmm.
They're essentially the same as in, say, an ant's cells.
Okay.
But those fundamental loops, through tiny variations in feedback over eons, fractured in wildly different recursive paths, like a branching river delta finding countless ways to the sea.
So same basic engine, but running completely different programs.
Kind of, leading to you listening to this and the ant, well, doing ant things, biting a stick, as the book puts it.
Right.
So the takeaway here is life isn't a ladder. It's not this linear progression towards complexity.
It's more like
A spiral fractal of randomness built on rhythm persistence. Chaos finding ways to repeat and sustain itself in ever more complex branching patterns.
okay, fractal randomness. Got it. But then the theory goes even further, into stuff we might not even be aware of.
Ah, yes. The surprise Goldilocks zones.
Things that standard science doesn't frack, but maybe AI could guess at, the source suggests. This is pretty speculative stuff.
It is, but it follows logically from the core idea of rhythmic motion being key.
So what are these theoretical zones? They're not like planetary orbits. They're more subtle.
Much more subtle, almost vibrational.
Like resonance thresholds in DNA replication, too much background noise or vibration, and maybe DNA just can't copy itself properly.
That's the idea. Or gamma ray exposure sync bands.
Oh.
Maybe it's not just the amount of radiation, but specific frequencies that disrupt the core motion loops of life more effectively.
Wow. Okay. What else?
Planetary sync pulse timing. This one's wild.
Oh.
The idea that Earth's rotation speed, the length of day and night, might need to match the natural refresh rate of biological loops.
So change the day length slightly.
And maybe complex cognition breaks down because your internal rhythms are out of sync with the planet.
That is unsettling. And
Yeah.
there's one more.
Gravitational rhythm buffering. The idea that moons might do more than stabilize tilt. They might act like gravitational metronomes, smoothing out rhythms essential for biological processes.
A backup timer for life.
Something like that. It suggests life is built on these incredibly fragile, recursive sync stacks, layer upon layer of nested rhythms,
So the conditions aren't just chemistry and temperature.
but also these deep, rhythmic, vibrational alignments. And if that's true, the source argues, then most universes never get close to pulling this off.
Which makes life even rarer than we thought.
Potentially, yes. It raises the stakes on our cosmic uniqueness if this framework holds any water.
Okay, let's bring this right down to earth, right down to the listener. The ultimate randomness, the book argues, is you. Look in the mirror.
Yeah.
You're described as a motion loop made of synced subloops, your cells,
Uh-huh.
built from sub-subloops, proteins, built from sub-subloops, atoms. It's loops all the way down,
Nested rhythms.
all happening in a body walking upright on a spinning rock with a moon stabilizer orbiting a yellow star in a spiral galaxy's outer arm. I mean, the stack of specific conditions is just immense.
It really puts things in perspective.
Makes you look at stirring your coffee differently, doesn't it? All those swirls.
Yeah, it does. But what's truly fascinating, and what the book really emphasizes,
Yeah.
is that somehow, out of all that nested chaos, all those sync accidents, you can think.
Right.
You can reflect on it, you can laugh, you can imagine things that don't exist.
That's the real miracle, maybe?
This isn't order in the old sense. The book calls it chaotic motion harmony at the highest level.
Chaotic harmony.
You, listening now, are a walking recursive sync glitch in a universe of random feedback explosions. And somehow, it works. You exist.
A walking sync glitch. Kind of like that. Okay, one more surprise.
Oh.
A bonus motion surprise, the source calls it. something potentially affecting your daily life.
Intriguing.
It's a theoretical concept called a macrosync alignment cascade.
Macrosync. Okay.
It suggests there might be brief periods, maybe related to our orbit or position in the galaxy, where subtle galactic motion vectors cause all structured motion on Earth's surface to sync up slightly better than usual.
Like a cosmic good rhythm day.
Exactly. Imagine one day birds seem to chirp louder, more in unison, plants bloom faster, your own thoughts feel clearer, sharper, everyone's just smoother. The source notes that, legacy science would probably call that superstition or confirmation bias.
Sure.
But motion theory offers this physical explanation. A temporary macrosync alignment cascade makes you wonder about those days when everything just seems to click right.
It does add a different potential layer to subjective experience.
So let's try and wrap this up. What's the big picture here?
Well, we started with galaxies as chaos.
Right, spiraling roulette wheels, stars as cosmic coin flips, planets as random remixes.
Earth as a stack of incredibly narrow sync accidents.
And life itself as millions of motion experiments leading to fractal randomness.
And yet, through all that fundamental randomness,
nested rhythm emerged. Stability, complexity, consciousness, all arising from chaos, finding ways to sync up.
So the ultimate takeaway from this perspective,
Go on.
you are the universe's greatest sync accident.
Wow. And the fact that you're even here, listening, thinking about this, asking why. That ability to reflect on your own improbable existence, maybe that's the most random motion miracle of them all.
Everything is connected. You've heard that phrase right. A million times, probably.
Oh, absolutely.
And it feels nice, maybe profound for a moment, but then it just kind of hangs there, a bit fuzzy.
Exactly. It often lives in that sort of philosophical space, doesn't it? Hinting at something, but not really explaining how. More feeling than physics.
Right. But what if it wasn't just a feeling? What if everything is connected was like a literal, physical, maybe even mathematical thing?
Well, that's exactly what we're diving into today. We're looking at motion theory.
Yeah, forget the vague vibes. This theory suggests it's about the actual structure of the universe.
Precisely. We've been digging into these excerpts from Everything is Connected Motion Theory's Ultimate Truth, and the main argument is that this connection isn't some side effect. It's fundamental. It is the structure.
Okay, let's get right into it then. What's the core idea here? How does motion theory explain this connection?
So the central concept, and it is a pretty big shift, is that motion isn't just something stuff does. It's what everything fundamentally is.
Wait, say that again? Motion is what things are.
Yeah. Think about matter, light, space, energy, even time. Motion theory views all of them as different arrangements, different structures of these basic units of motion. They call them motion loops sometimes.
Motion loops. Oh, okay, interesting. So if everything is just arrangements of motion, how does that automatically connect everything?
Well, think about it. If the most basic ingredients of reality are these patterns of motion and they all exist within the same dynamic field.
Now they're already linked.
Exactly. The connection doesn't need to be established between separate things because there aren't fundamentally separate things. It's all interwoven from the get-go. It's all part of the same fabric of structured motion.
Huh. That really does flip the usual picture.
Huh.
We normally think, little particles first, then forces connecting them.
Right.
But this sounds like the connection itself is primary, which makes me think, what about something really weird like quantum entanglement?
Yes. Well, what's fascinating is how the theory looks at particles themselves. They aren't seen as tiny separate billiard balls. Okay.
They're described more like stable, repeating rhythms, like little whirlpools of motion within this bigger underlying sea of motion.
Rhythms. Okay. And how do these rhythms interact, if not forces?
They influence each other through something called synchronization gradients.
Synchronization gradients, right.
Yeah.
What does that mean exactly?
Imagine you have a bunch of pendulum clocks hanging on the same wall. Even if they start out of sync.
They eventually start swinging together.
Often, yeah. They influence each other through tiny vibrations in the wall, right? Without directly touching. Motion theory suggests something similar happens fundamentally. These motion loops, these rhythms, they tend to align their patterns, they sync up, creating these gradients of shared rhythm.
And that's how entanglement fits in, the whole spooky action at a distance thing.
Exactly. From this viewpoint, entangled particles aren't two separate things sending secret messages.
They're what?
They're described as parts of the same original rhythmic pattern. They never really separated in that sense. So when you observe one, the other instantly shows the corresponding property because it's part of the same dance.
Precisely. It's not reacting. It's just continuing. It's part of that shared synchronized pattern. Like, imagine plucking one end of a guitar string. The whole string vibrates, right? Both ends are part of the same event.
So no faster than light messages zipping back and forth.
Not needed in this model. It's about maintaining that inherent relationship that was established when the pattern formed. The connection wasn't really broken by space. Space just changes the local conditions, maybe. And they talk about sync drift, too. That's their explanation for why entanglement seems to fade. Decoherence, they say, isn't information loss. It's the rhythm losing its original fidelity, its sharpness.
That is a profoundly different take, okay? And does this rhythmic idea apply upwards?
Yeah.
To the big forces like gravity?
It does. This is where it gets really interesting, I think. Motion theory reinterprets gravity, electromagnetism, even the nuclear forces, not as fundamental forces carried by particles, but as emergent effects. Effects arising from these deeper rhythmic relationships and how structured motion behaves.
Okay, let's tackle gravity then. If it's not mass attracting mass, what is it?
Gravity, in this framework, is seen as a tendency for motion loops to converge, to move towards areas where the background motion is more synchronized, more coherent.
So like finding the strongest beat on the dance floor.
Kind of, yeah. Imagine regions where the universal rhythm is stronger, more organized. Other motion patterns, other stuff will naturally tend to get drawn into that rhythm, align with it. That's what we perceive as gravity. It's more about alignment than pulling.
Which might help bridge that gap between general relativity and quantum mechanics.
That's one of the potential implications, yes. Seeing gravity as emerging from these deeper quantum level synchronization dynamics.
Okay, so it's motion aligning with more synchronized motion.
Got it. What about electromagnetism? Also reinterpreted through motion. Think of it as specific kinds of structured ripples or disturbances propagating through this motion field, like patterns of motion redistribution within these rhythm zones.
And these patterns then affect other motion loops nearby.
Right, leading to what we measure as electric and magnetic effects. It's about how these structured motion patterns influence the synchronization of others.
And the strong and weak forces inside the atom.
Those are viewed more as internal dynamics, mechanisms that maintain the stability within a motion loop, or define the thresholds where that internal sync can break down or change. So less about external forces, more about the integrity of the rhythm itself.
Wow. So the universe isn't run by four separate forces pulling strings.
But rather by this underlying web of rhythmic relationships. That's the picture, yeah.
The dance floor analogy really works then.
Yeah.
Dancers influencing each other through the shared music, the shared rhythm, not by grabbing each other.
Exactly. From particles to galaxies, everything is responding to and contributing to this overall cosmic rhythm.
Okay, the implications are huge. What about us?
Yeah.
Biology. Life.
Yeah, motion theory looks at the human body as this incredibly complex rhythm stack.
A rhythm stack.
Think about it. Oscillating cells, proteins folding in rhythmic ways, neurons firing in complex patterns, heartbeats, breathing. It's rhythms all the way down and all the way up. A hierarchy of synchronized motion.
So being alive is basically maintaining this complex symphony of rhythms.
That's the idea.
Yeah.
And your sense of self, your identity, it's not some extra ghost in the machine. It's the persistent coherence, the stable pattern of all this synchronized activity that makes up you.
And thoughts. Feelings.
Thoughts are framed as transient sync patterns in the brain, moments where large networks of neurons achieve a temporary specific coherence, like a flash of synchronized rhythm that pops into awareness and then fades.
Okay.
And you know that feeling of connection you get sometimes, meditating maybe, or dancing or singing with others? The theory suggests that's not just woo, it's potentially your internal bodily rhythms, literally synchronizing and training with external rhythms, be it music, nature, or other people. It's physics happening. Rhythmic entrainment.
Grounding those experiences in physics. That's fascinating. Does it go even bigger to how we perceive the cosmos? Looking at a star, say.
Absolutely. If synchronicity is fundamental, then seeing a distant star isn't just about passively catching old photons.
It's more active.
It could involve our own internal rhythms actually synchronizing in some way with the ongoing rhythmic pattern of that star across vast distances.
So we're not just seeing the past light, we're kind of tuning in.
That's a way to put it, yeah. Perception as an active resolution of motion across these universal rhythm gradients. We align to the star's rhythm, perhaps, rather than it just shining at us.
And telescopes, those images of galaxies billions of light years away.
They're seen as capturing a motion lock-in. You're locking onto the pattern. Now, the sync bandwidth might be really degraded over that distance, so the resolution of the rhythmic information is lower.
Less sharp, maybe.
Exactly, but it's still reflecting the star or galaxy's state within the constraints of that connection. It's a present moment connection, just a very low bandwidth one for very distant things.
So bottom line, everything we see, everything we are, from tiny particles to huge galaxies, it's all already part of one vast interconnected system of motion.
That's the core message. And consciousness itself, in this view, it's what happens when motion becomes complex enough to start referencing itself, when the rhythms become aware of their own patterns.
So the universe isn't just made of stuff, it's made of rhythm.
Primarily, yes. And that phrase, everything is connected, it stops being just a nice thought.
It becomes a mechanical description, a mathematical one even.
According to motion theory, yes. It's literal truth based on structured motion and synchronization. Connection isn't something we need to build, it's already here. We're just maybe remembering it or figuring out how it works.
Wow, that gives that simple phrase so much more weight. Okay, so if this is true, if connection is fundamental, baked into the physics of motion, what does that mean for us? For how we interact with the world, with each other?
It certainly opens up new ways to think.
It really does. Thinking about a universe built on rhythm, not just separate bits. Thanks for unpacking all that with me.
My pleasure. A fascinating topic.
And for you listening, here's something to chew on. If connection is truly fundamental, woven into reality through motion, how might that change your perspective, your place in this cosmic dance? What opens up when you see the universe not just as objects, but as this incredible symphony of rhythms? Something to think about until our next deep dive.